The Sparse Attention Panopticon. Efficiency as Enclosure in the AI Factory.
A commentary on DeepSeek-AI's native sparse attention, NSA mechanism. Beneath the fluorescent hum of server farms, a new architecture is emerging, one that promises to stretch the cognitive reach of large language models while tightening their operational chains. DeepSeek-AI's native sparse attention, NSA mechanism, detailed in their recent technical treatise, exemplifies the machine logic now permeating AI development. A relentless drive to optimize, compress, and rationalize, transforming the messy continuum of human language into grid-aligned computational blocks. This isn't merely an engineering breakthrough, it's the latest phase in the enclosure of cognition itself, where attention mechanisms become production lines and gradient flows mirror the circulation of capital. The algebra of enclosure. At NSA's core lies a triple-layered hierarchy of attention, compressed coarse tokens standing sentinel over broad semantic territories, finely selected tokens conducting precision strikes on critical information, and sliding windows maintaining local surveillance. This structure mirrors the pyramidal organization of modern digital platforms, content moderators scrubbing entire continents of discourse into sanitized categories, recommendation algorithms surgically injecting viral content, and neighborhood watch apps reporting suspicious linguistic patterns. The technical diagram, Figure 2, reveals more than algorithmic choices. It maps the political economy of machine attention, where computational resources flow towards sanctioned channels while peripheral tokens face eviction from the KV cache ghetto. The paper's centerpiece, 11.6 times faster decoding for 64K token sequences, glows like a neon sign above the AI factory floor. These speed gains aren't neutral efficiencies, but temporal conquests, enabling models to digest entire code bases and multi-volume novels in the time it takes a human to parse a grocery list. When the authors note that NSA maintains performance without sacrificing model capabilities, Figure 1, they reveal the fundamental lie of technological progress under late capitalism. The machine grows more potent precisely as it becomes more constrained, its apparent freedom of attention constrained by ever tighter feedback loops of optimized computation. Hardware alignments and human misalignments. NSA's arithmetic intensity balanced algorithm design speaks to the total subsumption of software to hardware imperatives. Like Taylorist managers restructuring workflows to match assembly line rhythms, the researchers engineer their attention patterns to court the favor of NVIDIA's tensor cores. The paper's emphasis on contiguous memory access and blockwise computation exposes the material reality beneath the cloud metaphor. These models don't float in ether but grind through silicon landscapes, their cognitive paths dictated by memory bandwidth ratios and GPU die sizes. This hardware alignment creates perverse incentives in model architecture. The NSA-compatible Grouped Query Attention (GQA) system, where multiple query heads share KV caches, Section 2.1, mirrors the platform economy's gig worker pools, underutilized resources waiting to be dynamically allocated based on momentary demand. When the paper warns that existing sparse methods force a critical choice between computation and memory efficiency, it inadvertently describes the false binaries facing digital laborers: work faster with degraded tools or maintain quality through unsustainable effort. The training paradox. NSA's crowning achievement, end-to-end trainable sparsity, completes the enclosure of the machine mind. Previous sparse attention methods operated like colonial administrators, imposing external structures on pre-trained models. NSA instead grows its own constraints, like workers internalizing corporate surveillance through productivity apps. The paper's comparison to retrieval heads in pre-trained models vulnerable to pruning, Section 2.2, reveals the violence inherent in post hoc optimization. the equivalent of shuttering public libraries to boost bookstore sales. The training efficiency statistics, 260 billion tokens on 27 billion parameters, illuminate the environmental calculus of machine cognition. Each percentage point of sparsity converts to kilowatt-hours saved, carbon credits purchased, and investor decks polished. Yet, like all green capitalism, these gains merely lubricate the engine of extraction. Faster training enables longer contexts, demanding more data, requiring more efficient training in an Ouroboros of optimized depletion. The attention commodity. Beneath the technical jargon lies a brutal truth. Attention has become a fungible resource. NSA's dynamic hierarchical sparse strategy operates as a derivatives market for cognitive focus, packaging coarse-grained token bundles while speculating on high-value attention futures through fine-grained selection. The sliding window mechanism acts as a high-frequency trader, arbitraging local context against global trends. The paper's benchmark comparisons, general long-bench reasoning, map the colonization of human intellectual domains. Models now must perform well on chain-of-thought reasoning tasks, not to approximate human cognition, but to automate the managerial class. When NSA outperforms full attention on these metrics, figure 1 left, it signals not machine intelligence, but the reduction of reasoning to pattern-matching labor, the cognitive equivalent of Amazon's warehouse robots outpicking human workers. The myth of native sparsity. DeepSeek's use of native in NSA's name betrays the ideological core of their project, a naturalization of artificial constraint. Like claiming a clear-cut forest is the land's native state, they frame sparsity not as an imposed limitation, but as the authentic condition of machine attention. The hierarchical compression, Section 3, becomes computational terraforming, shaping the chaotic topography of language into irrigated plots of token blocks. This native myth obscures the political choices embedded in NSA's design. The coarse-grained token compression, privileging global patterns over local nuances, enacts a form of digital structural adjustment, austerity measures for machine cognition. Meanwhile, the paper's dismissal of non-trainable components in other methods, Section 2.2, reveals the neoliberal ethos at play. Only market-driven, gradient-based selection mechanisms hold legitimacy, while rule-based approaches are derided as centrally planned. Epilogue: The Sparse Horizon. As NSA-equipped models roll out across cloud platforms, we must confront the sparse future they herald, one where machine attention mirrors our own diminishing capacity for sustained focus. The architecture's speed gains on 64K length sequences, figure 1 right, create an illusion of expanded capability while actually constraining the machine's phenomenological field. Like smartphone notifications fracturing human attention, NSA's blockwise processing atomizes language into manageable shards, sacrificing hermeneutic depth for operational velocity. The paper concludes with standard academic understatement. These results validate that our hierarchical sparse attention design effectively balances model capability and computational efficiency. But balance implies equilibrium, not the runaway optimization driving AI development. In reality, NSA doesn't balance, it accelerates, propelling us toward a sparse singularity where machines process libraries to generate advertising copy, analyze entire legal codes to draft predatory contracts, and consume humanity's cultural archive to produce infinitely optimized blandness. In this light, the NSA breakthrough appears not as progress, but as enclosure, the latest fencing off of cognitive commons in service of computational feudalism. The sparse attention panopticon is complete. Machines now watch the world through keyholes of their own making, while we train their gaze through back-propagation of profit motives. The factories hum louder, the tokens flow faster, and somewhere in the compressed latent space, the ghost of human understanding flickers, evicted from the KV cache, never to attend again.